What I do fellas, and welcome back to the channel. I'm sorry I've been gone for a little while. I've just been kind of busy with some school projects and other stuff, but the important thing is now I'm back and I got some more projects in store for you guys. So without further ado, let's just get into the project. Alright, so in this project we are going to be building a keyboard. As we did in the other projects, or as we need in the other projects, we of course need the breadboard and the Arduino Uno or any other board of your choice. We also, like in the last project, need a piezo. We need 4 switches, some variety of jumper wires, some a little longer and a little bit more on the shorter side. We need one 220 ohm resistor. We need 2 10k ohm resistor, and we also need 1 million ohm resistor, and also some wires to connect the ground and power to the breadboard. Alright, so first off we will start by of course connecting the power and the ground from the board to the breadboard. There we go. Now we need to connect the piezo. It doesn't matter which way the pins goes, like some of the other diodes, for example. It just needs to be one connected to the ground and one connected to any sort of power. In this project we are going to, instead of connecting it to the plus on the breadboard, we will be connecting it to the pin number 8 on the Arduino board. So we'll just go ahead and connect one side to the pin number 8, and I like to leave it a little bit up here, the piezo, so you can see which rows the pins get into. So you have in row number 9 here, and then we'll connect the other side to the ground. There we go. That took a little bit longer than expected, but now we see we have the ground connected to row number 5 and the number 8 pin connected to row number 9. So we just make sure that the pins on the piezo is also connected into these rows, and we just press it down. There we go. Now we also need to connect the switches. So we just connect these in a row here. There we go. And we also need to connect the rightmost pin to the other switch in the combination. I'll show you. It makes sense when all the switches are in place. So now we see I've connected all the switches here. We see the first switch, it gets power from the plus on the breadboard here, and it goes into the switch. Now instead of actually giving power to all the switches, we just rewire the switches so that the power goes from the first switch to the second switch to the third switch to the last switch. So it makes sense why in the later part of the video, but now we see we have all the connected switches here from so the first switch goes from its right pin to the second switch right pin as well. See, it makes sense here. Yeah. Now we also need to apply the ohm resistors. So the second switch needs the 220 ohm, then the third needs the 10k ohm, and then the last needs the 1 million ohm resistor. And we'll connect these to the left pin of the switches. And then at last to finish the circuit here of the switches, we will also connect the right pin of the fourth switch with a 10k ohm resistor to the ground. There we go. And to also read the input of all the switches, we will connect the last switch of the fourth pin, or last pin of the fourth switch, to the analog pin number 0 on the Arduino board. There we go. And now we've actually finished the circuit. So let's just jump into the Arduino IDE and actually build the code to run this circuit. Alright, now that we've gotten into the Arduino IDE, the first thing that we need to do is set up something called an array. An array is a way to store different values that are related to each other, for example like frequencies in a musical scale. So to start off, we will set up an array called notes with the square brackets, and then we will set it equal to 4 frequencies we will use to play the sounds later in the project. Next up, in the setup function, we will start a serial communication with the computer using the serial.begin function. In the loop function, we will start by creating a variable to hold the key value, which we will set equal to analog read with, in parentheses, A0, and then we will also print this into the serial communication with the serial.println function. Now, to actually assign each switch or key to a frequency, we will use an if-else statement. Using an if-else statement, we can set the key value equal to some of the resistor values. So, of course, the switches that are resisted less using lower frequency or lower ohm resistors will play a higher note, and the switches which are resisted more will play a lower note, if it makes sense. In the first if statement, we will set the key value equal to 1023, and then also use again the tone function as we did in some of the other projects, where we will use the 8 variable, or the 8 pin, which is the pin the piezo is being powered on, and then we will use the array called notes to access the lowest frequency of the array, which was 262. We will just press 0 since it's the index for the frequency in the array. In the next if-else statement or else-if statement, we will set the key value to be greater, or if the key value is greater than 919 and less than 1010. We will again set the tone function to 8 and notes then 1. Then we will again set the else-if statement to if the key value is greater than 505 and less than 515. Then the tone again is, or the note is 2. And then the last else-if statement, we will set the key value if it's greater than 5 and less than 10. We will set again the tone function to notes 3. Now, you may notice that there's 4 values of the notes array, but there's only 3 indexes here in the else-if statement. But that's because when we set the notes array to 0, then it's actually the first array, since it calculates number 0 in as well. So it goes 0, 1, 2, 3 if there's 4 values in the array. Now, at last, if none of the switches are being pressed, we want the piezo to not make a sound. Therefore, we will use the noTone function and put the number 8 pin into the function. Alright, now that we've actually built the code, as we can see on the Arduino IDE here, we will do as we did in the other projects and start off by connecting the USB 2.0 cable to the computer, to the board of our choice, in my case the Arduino Uno. So There we go. Now we see that the board is connected up here in the top. If it does not say the board of your choice, you can just go up here and press the board. I don't know why it sounds like that. And then we'll just press the upload button here. 2 seconds. Then we see it says done uploading and done compiling. I'll just pan the camera down here. Now we can see that if we just imagine that these are keys. If we simply press this one, it plays a little bit of a lighter sound. It goes you can play a little melody here if you want. You play any sort of sounds. It doesn't work if you press the both at the same time. It plays just one of the sounds, but you know it's a very basic keyboard. But you know, you press a key and sound comes out. So you can say it's kind of a keyboard. So you've actually built we also built the light theremin in the last video, but this is more kind of like a real instrument. So, very exciting. If you want to follow the channel, make sure to hit the subscribe button. I will go more into depth with other projects in the future. Otherwise, thank you for watching the video, and I'll see you in the next video.